Okay, so today we're going to be dividing polynomials, and this is what we call polynomial long division, and you'll see here from this example, it looks exactly like the numerical long division that you learned back in, what did they do this now, like the 3rd or 4th grade? And notice, the numbers are exactly the same. See 672, except over here we have 6x squared plus 7x plus 2, same thing. Over here, 21, 2x plus 1. Notice on top, same answer, 32, 3x plus 2, all the same numbers. It works all the same way. So what I'm going to do is go through a couple of examples with you. So let's go down here towards the bottom of the page, and we're going to take a look at example A. So the x plus 5 is going to go out in front. Put your little division symbol here. In there, put your polynomial. Whoops, 23x minus 16. What you want to ask yourself to get this thing started, and we did this in the prep video that we watched, is you want to look at this guy x right here, and this guy, the 4x squared. And you want to ask yourself, what do I need to multiply x by to get as an answer 4x squared? 4x. So what I'm going to do, take that 4x and we're going to put it up top side here. Now, take that 4x and we're going to multiply it by the x plus 5 using distribution. So 4x times x is 4x squared, and I'm going to write that right underneath the like term 4x squared. And 4x times 5 is 20x. So I'm going to write that right under the 23x so that my like terms are vertically aligned. Now, do you remember when you're doing regular long division from back from the 3rd grade that at this point you would subtract? But I hope I can convince you that subtracting with algebraic expressions is a little cumbersome. It is easier to add them. So what we're going to do is change the signs and add. So I'm going to change this sign and this sign, and now we're going to add. Now, your first column cancels out to 0, and it always will, or you've done something wrong. Right here I have 23x and negative 20x, which is going to give me 3x. And at this point, I am going to bring down my last term. All right, so now I'm still looking at this x that I got out front, and I'm looking at this 3x. And I have to ask myself, what do I need to multiply this x by to get 3x? 3. So what I'm going to do, and it's a positive 3, so go up here and you're going to write plus 3 for positive 3. So again, I'm going to do some distribution and multiply 3 times the x plus 5 using distribution, and I'm going to get a positive 3x, and I'm going to get a positive 15. Fair enough? Okay, change both the signs. Whatever they were, change them to the other sign. Now, we're going to add. So these, when you add them, cancels out to 0. And your first column always will, or you've already gone wrong. Here, I've got negative 16 and negative 15, and that gives me negative 31. This guy right here is what we would call the remainder. Okay? And when I'm giving my answer, I need to give the remainder as part of my answer. So here's my answer. See my 4x plus 3 up here, this guy? That goes to my answer. So my answer is 4x plus 3, all right, minus 31 divided by whatever is here, x plus 5. Does this ring a bell from the prep video that you watched? Yes. Do you want me to do another one or proceed on to a more difficult one? You want me to do this one, or which is just like this, or go to the more difficult? We'll go to the more difficult one. So let's turn the page. Okay. Now, here's what I'm going to do. I've got this question that says, is this a factor of this? And in order to answer that, what I need to do is polynomial long division, but I need to see if when I do it, my very last answer, my remainder, is 0. If my remainder is 0, it is a factor. If it's not 0, then it isn't a factor. But keep in mind, and maybe you remember this from the video, when you're doing polynomial long division, all of your powers have to be represented. So in this, I've got fourth, third, second. I have no first power, right? No x term. Need to put 0x in that spot, okay? The place needs to be held by the 0. So I have 3x to the fourth minus 4x to the third plus 12x squared plus 0x plus 5. That spot needs to be held with a 0, okay? Otherwise, what happens is when you go to do this process, your columns won't line up in terms of having like terms on top and below each other. It'll be all messed up and it'll wreck. Now, guess what we're missing right here? The x term. So we need to put it out here. So this is going to be x squared plus 0x plus 1. Now, everything else works the same as it just worked. So we're going to take a look at this and take a look at this. What do I need to multiply x squared by to get 3x to the fourth? 3x squared. So what I'm going to do, go to the top, and I'm going to write 3x squared. And now I'm going to take 3x squared, and I'm going to multiply it by this right here using distribution. So when I do this one here, I'm going to get 3x to the fourth. When I do this one, I'm going to get 0x to the third, right? And when I do this one, I've got 3x squared. Okay, change all the signs. Minus, 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 and we're going to add. So notice this will cancel out. This is negative 4x to the third. This is positive 9x squared. Bring one more term down. So let's bring down that 0x. So now I'm taking a look at that x squared, and I'm taking a look at this. What do I need to multiply that x squared by to get negative 4x to the third? Negative 4x. So we're going to put that up here. Okay? And we are going to multiply it by this using distribution. All right? There we go. Negative 4x times x squared is negative 4x to the third. Times 0 is, of course, plus 0x squared. And times 1 is going to give me right here a negative 4x. Would you agree so far for that? Okay. Notice, in all my columns I have all like terms, right? Change all three signs. So this becomes plus, this becomes minus, this becomes plus. And that the reason I do it in red pen is so I can keep track of what my real sign is, because I'm changing it from what it once was to what I need it to be. And do you see how this cancels out to 0? This gives us 9x squared, and this is then plus 4x, and bring down the 5, right? Okay, so now, take a look at that x squared, and take a look at this, 9x squared. What do you have to multiply x squared by to get 9x squared? 9. So we're going to put plus 9 up here. Okay. Now the ticket is, when we do this last step, because we've gotten to a constant term in our answer, this is going to be our last go around with this. If our remainder is 0, this is a factor. If it is not 0, it is not a factor. Okay. So I've got 9 times x squared is 9x squared. 9 times 0x is 0x. 9 times 1 is 9. Change all my signs. And these guys cancel, and I have 4x minus 4. Is that 0? No, it is not. So therefore, this is not a factor. So this is a big, resounding no. Not a factor. If it had come out to be a 0 remainder, it would have been a factor, but it isn't, because we didn't get 0 as a remainder. So now, I know that this is a cumbersome process, and look how much paper it takes up. I'm going to show you synthetic division, and this is really fast, and maybe not as easy to understand, but much faster. All right, so here is synthetic division. Here's what we do. With synthetic division, here's the thing about synthetic division. When you are using it, do you see how over here we divided by x squared plus 1? You can't do this with synthetic division. It won't work. The only kind of problem that you can do with synthetic division is where you are dividing by x minus a, where a is some number. So it can only be that. All right?
X minus or x plus 1?
Well, if it's plus, wouldn't it mean that a is negative? Yeah. So here we have x plus 2, right? We're dividing by x plus 2. So wouldn't that mean that in the form x minus a is really a negative 2? X minus negative 2 is how you get x plus 2. So here's what you're going to do. You take that negative 2, that a value, and you're going to plunk it right out here, and you're going to put a half of a box around it. Okay? This is in the format x minus a. This here is your a. The way to get x plus 2 is you have x minus negative 2. So your a must have been a negative 2, because that's the only way that you could have gotten x plus a. Okay. So now we're going to take, what we're going to do is take all of our coefficients right here. A 1, a negative 14, a 51, and a negative 54. Now the same thing applies. If you're missing a term, if it isn't represented, you need to plunk a 0 there. Okay, so just like with the long division. So I have a 1, a negative 14, a 51, and a negative 54. Okay? And now leave a space and put a line. All right, follow closely. First thing you're going to do, take this and drop him down here.
You always do this in the first one?
Yep, you're always going to do that to the first one. Take this times this, and that's negative 2, right? Put it here. We're going to keep doing this pattern now. And what you want to do at this point, add these. So you get negative 16, right? Multiply these two. You get 32, right? That goes here. Add. So what is that, 83? Okay. Multiply. So we keep going back and forth between add and multiply, add and multiply. So we're now on to multiply here. So I've got 83 times negative 2 is negative 166. Fair enough? And that goes there. Add. So when I add those, I get negative 220, right? Okay. This guy right here is your remainder. Okay? Now, do you see how you started with x to the third? Okay. Drop a power. This is your x squared term. This is your x term. And you just keep dropping a power. So your answer is x squared minus 16x plus 83 and then minus 220 over x plus 2. And the x plus 2 is what you were dividing by in the first place. Okay, do you see how fast that was? Okay, that's why people like this. It drives me up the wall because I don't think it makes as much sense, but it's fast. Yes, ma'am?
So your -2 comes from your A, right?
Yes.
So you plug in your A where the -2 is, and then you add the -14 to the -2.
Yes.
And that's how you got that, and you multiply 16 by 51.
Nope, 16 by -2. Everything's being multiplied by -2. You're going right down the row, multiplying by -2. Let's do another example. All right? So go down here to the next example. Now, do you see how we're missing an x squared term? We need to put a 0 in that spot. So first of all, let me ask you, what is A? 7. So you're going to put a 7 here and put a little box around it. Now your numbers, you're starting out with your coefficients 1. You don't have an x squared term, so you need to put a 0. Then you've got a -57. And then you've got a 56, okay? And all your terms from your highest power down are represented, okay? Leave a space and draw a line. The way we start this, just bring that first one right down, okay? Now, multiply. So 1 times 7 is 7. Add. Multiply. 7 times 7. Add. What does this give us? -8. Multiply. Add. Guess what? No remainder. Right? No remainder. Do you want to know what this means? This means x minus 7 is a factor of x to the third minus 57x plus 56. It is a factor. We have found a factor. So now, what is your answer? Remember, we drop our power down by 1, so this is an x squared term. This is an x term. And that's by itself. So here's what we've got. X squared plus 7x minus 8. Now, I'm going to show you something even above and beyond that. Would you agree? We can factor this in our head, right?
Yeah.
This is x plus 8x minus 1, right? So it means that this factors to x minus 7 because we found that factor. And if you factor this, you get x plus 8, x minus 1. So we factored into 3 binomials a cubic function. And that is going to take us into what we're going to keep on doing from here on out.
Wait, why would you do x minus 1 again?
Multiplies to -8, adds to positive 7. 8 and -1. Emma.
In the first one, when you dropped it down a power, it was like an x, and you dropped the x down, so it would go from like x to the third to x to the second.
Yep.
But the x, if it's just x, does it just go away?
Yes.
But then in this one, it was 57x, but we put it back in.
And it dropped down to just an 8.
Right. Oh, that was the 8 that had. Oh.
Right?
Never mind. Oh wait, no.
This had an x.
Oh yeah.
This column, it dropped down 1, so it just became an 8 with no x. All right, one last thing to do. This is the coolest thing. This is a super fast way to do this. The remainder theorem. If you divide a polynomial by x minus a, using synthetic division for example, the remainder is p of a. So this is really cool. Do you remember how in order to find p of 3 we would do this, right? P of 3 equals 3 to the 5th minus 2 times 3 to the 3rd minus 3 squared plus 2. And we'd have to figure all that out, right? I'm going to show you a much faster way to do this. And once you get the hang of synthetic division and how fast it goes, you will love this. All right? So somebody, who would like to get on your calculator and figure out what this is for us? All right. I'll do it later. So here we go. I need to find P of 3. Put the 3 over there in the box. We're going to start here. I've got x to the 5th. I'm going to put a 1 because that's its coefficient. A 0 for the x to the 4th term. A negative 2 for the x to the 3rd. A negative 1 for the x squared. A 0 for the x term. And then a 2. Okay, because all the powers have to be represented. Okay, drop the 1 down. Multiply. 1 times 3 is 3. Add 3. 3 times 3 is 9. Add 7. 3 times 7 is 21. Add, and you get 20. 3 times 20 is 60. Add, and you get 60. 3 times 60 is 180. Add, and you get 182. So let's hang on to that for a second.
I just put in the calculator.
It's 182.
Yes, I told you, this equals this. It equals that. This is so awful, this is so fast, and it gives you the answer. This was easy. I never got a calculator out to do this. You cannot do this without a calculator. And this never used a calculator the whole time we did it. Went and did the whole thing by hand.
But how?
Yes.
How do you do it? Is it worth it?